I'm Nick Chrisman, and I'm the author of this book, Charting the Unknown. We decided to provide a certain number of resources at the back of the book that sort of grew. We started thinking, well, we'll put in all the publications of the lab, and then we'll put a list of all the lab staff, and we'll sort of say, well, where are these lab staff? Where'd they go? Where are these people now? And then somebody had the crazy idea that we would interview them and talk to them now about what they're currently doing. And so that's what you're seeing. So I joined the lab in 1972. There were about 6 full-time staff at the lab at that point. Down from about 40 2 years before. And my job was programmer. I was meant to clean up Calform, make it ready to distribute. I was meant to get databases ready. One of the databases was a description of the county outlines in the United States called the county dime file that had been restructured from a format from the Bureau of Public Roads into a dime format. And I looked at this description and I learned something about dime, which was a project that had started a number of years before through the New Haven Census Use Studies. And I read all the documentation, and I liked the dime format. And I thought I'd write myself a dime converter so that we could take anything that was in a dime format and turn it into lab formats so that all of our users could make maps with free data. And so I started writing a dime converter, and it turned out that once you started writing a dime converter, you were writing a whole bunch of other converters. And I ended up writing a package that quickly got called polyvert. And polyvert was okay for first shot, but it really had a bunch of weaknesses. You always discover the weaknesses when you try to push a program. What happened with us was that in 1975, we took on a project for the Census Bureau. Well, we didn't know how bad the data, you never know how bad the data are when you start. So we said, oh, no problem, we can convert this stuff with polyvert. And, more or less, small metropolitan area. Sure enough, we wrote a little converter. We put this stuff into an input order. First problem, Altoona, Pennsylvania. Went right through, no problem. So we tried the next city. It wasn't too bad. And there were a few little things to edit, and we figured, no problem. Let's go on. Let's try bigger problems. And after a while, we realized, well, polyvert isn't big enough for this thing, so let's just jack it up. So we had polyvert.big, and then that wasn't big enough. We had polyvert.bigger, and then we had polyvert.biggest, and then we had polyvert.oink. And oink was far beyond what that technology was going to work for. And this is a project that I was working on with Dennis White. Dennis was actually working with Census Bureau, and I was behind him with the broom trying to keep polyvert working. And polyvert eventually failed. Polyvert failed because the segments were coming in random order, and polyvert was trying to stitch them back together again, and it was a mess. And so we were trying to figure out a way out of our problem, because we could barely do Boston. We knew we couldn't do Chicago, and LA was looming out there. We had to complete LA to complete the project, and LA was an order of magnitude bigger than the ones that we could do. LA was big. LA was bad. LA was thousands of polygons. And we weren't ready for it. And we were waiting around at the computer center as you usually waited around at the computer center for your output to come out. And I had this idea that there was another way. I was going to be able to take all the segments that were coming out of Dennis's processor. I was going to be able to put them together into the little pieces and not do it the polyvert way, but do it dynamically with data structures that reacted to the flow of the data. And it wasn't seeing it as a database, but it was seeing it as a processor. It was seeing it as an online processor, something that was happening on the fly.